let's jump right into this explainer on the anatomy of large format UV flatbed printers. Look, if you're a production manager, you already know that keeping a print facility running efficiently is about way more than just hitting print. It's about optimizing your throughput and aggressively managing those heavy operational costs. So today, we're going to look under the hood. We're translating some pretty complex engineering into actionable insights for your production floor.
We've got a great lineup today. We're starting with the core of UV printing, then moving through the ink ecosystem, high-performance printhead technology, and UV LED curing systems. After that, we'll tackle managing power consumption and wrap it all up with the key industrial specifications you need to know.
All right, Section 1, the core of UV printing, setting the scale.
When we talk about industrial scale, we are talking about absolute workhorses. Machines like the Acuity Prime can easily handle up to 150 square meters per hour. They feature these sweeping vacuum tables designed to process incredibly diverse materials, everything from massive rigid panels to heavy roll-to-roll media. Because these are such massive investments, their capabilities literally dictate the workflow of your entire shop floor.
Moving on to Section 2, let's look at the ink ecosystem, basically the highly specialized fuel for these machines.
The whole printing process here is incredibly sequential. First, the printheads lay down CMYK to create millions of process colors. Then, they follow that up almost instantly with a specialized white ink. And finally, they lock it all in with a protective, clear varnish. It's this beautiful precision buildup on the substrate, firing specific channels in an exact order so you get maximum vibrancy and durability, all in a single pass.
Now, the white ink, that is an absolute game changer. Unlike traditional paper printing where the white of the page is your default base, industrial flatbeds actually have to create their own base layer. It acts exactly like a primer. This is what allows you to print completely opaquely on glass, metal, or even dark acrylics, guaranteeing that your colors pop beautifully no matter what kind of crazy material you're feeding into it.
And to top it all off, we have clear varnish. This isn't just some aesthetic upsell for cool textured or spot gloss effects, though it's great for that. It acts as a vital protective shield. Adding varnish is practically mandatory for materials that need to survive the elements, because it significantly extends the lifespan of your outdoor applications. It's doing double duty, looking great and fighting off scratches and weather damage.
All right, Section 3, let's talk about high-performance printhead technology, the actual engine of the system.
Think about components like the Kyocera KJ4 series inkjet printhead for a second. This is a brilliant example of the piezo actuator technology that drives precision dot placement on a truly industrial scale. It's a highly intricate piece of tech that uses advanced ceramics to rapidly expand and contract. It is literally firing individual ink droplets onto the media below with just breathtaking speed and accuracy. And the specs on these industry standard heads are just insane. We're talking 1200 dpi grayscale resolution and continuous ink recirculation, which ensures extreme reliability. They also use variable drop sizes, from tiny 3.5 picoliter drops for superfine text, all the way up to 21 picoliters for heavy, solid color coverage. But crucially, they feature crash detect protection systems. These safeguard your highly expensive printheads from costly media strikes, which is an absolute lifesaver for minimizing downtime. Which brings us to Section 4, UV LED curing systems. I like to think of this as the accelerator. Once that ink is down, it needs to cure instantly. Now, chemical formulators have to be incredibly precise here. UVA and UVB wavelengths penetrate deeply, right down to where the ink meets the substrate. Meanwhile, UVC wavelengths are primarily absorbed in the surface layers. So, to get that perfect, strong cure, the UV lamp's specific wavelengths have to perfectly match the photoinitiators mixed into the ink. That's how you get a hard, durable finish that adheres perfectly without ending up with a tacky surface. But the real kicker is the sheer power we have access to today. Modern water-cooled UV LEDs operating at 395 nanometers can output peak irradiances of up to an incredible 24 watts per square centimeter. This is a massive leap over traditional mercury arc lamps. It translates to faster curing, a lot less heat warping your sensitive materials, and ultimately, significantly higher throughput for your shop. Of course, all that rapid curing power comes at a cost, leading us into Section 5, managing power consumption. This is the overhead reality we all have to deal with. You know, while a small entry-level printer might just sip roughly 1,000 watts, industrial machines are a whole different beast.
When you start adding multiple UV lamps, large carriage motors, and heavy-duty vacuum systems, you can aggressively push a large format flatbed to 5,000 watts or even more. These components compound quickly, creating a very substantial electrical load.
And you've got to keep in mind those UV lamps, they are absolutely your biggest culprits. They can easily add 1,000 to 2,000 extra watts to your baseline load, because even though LED technology is way more efficient than older styles, guaranteeing a complete lightning-fast cure across a massive print bed still demands some serious electricity. This hidden overhead is a really critical factor that you absolutely must model into your production cost estimates every single month.
All right, let's wrap this up with Section 6, Key Industrial Specifications. This is where we talk about your hard floor requirements.
To truly grasp the footprint of this equipment, you really have to look at the maximum operational parameters of these massive vacuum tables. As you map out your production floor, you aren't just making room for the printer itself. You have to factor in the spatial footprint required to actually load, unload, and safely maneuver massive, heavy, rigid boards all the way around that bed. Let's look at the hard numbers. You're handling media up to 51 millimeters thick. You're supporting bed weights of 45 kilograms per square meter, often utilizing up to 6 adjustable vacuum zones to keep things flat. But what's absolutely vital here is the supporting infrastructure. You definitely aren't just plugging one of these into a standard wall socket. We are talking about needing a 3-phase, 400-volt power supply, plus dedicated industrial air lines pulling at least 40 cubic meters per minute just to manage the vacuum hold down and all the internal pneumatics. It's a serious setup. So that leaves us with one really vital question to think about. Considering the incredible throughput capabilities we've just uncovered, along with those heavy operational requirements, is your facility truly equipped with the power, space, and infrastructure to maximize a machine like this? An industrial UV flatbed is a phenomenal, game-changing tool, but its performance is completely tethered to the environment you put it in. Think about your current setup right now. Are you actually ready to elevate your operations to this level? Thanks so much for joining me on this explainer. Catch you next time.